Today I want to talk about threading in Lucee. Threading makes sense if you want to execute code that takes a long time and you don't want to wait for the result, or you want to execute code parallel to other code. Then threading makes sense. Take this simple example. We have a function that naps for a second. So we have 1,000 milliseconds, what makes a second. So we call that function, and we then output the time it took to execute that function. So when I execute that, you see it naps for a second, so it took a second, more or less. But maybe we don't want to wait for this function to execute because we are not interested in the result. We store the result in a data source, or we call a web service, and we simply want to log if that web service is available, or give us the latest weather forecast. And we simply want to store that in a data source and then access the latest data from the data source. So we don't care that how long it takes and the current result. We simply want to store that. So in that case, I simply use the tag thread and surround the sleep call in that case, or what that would be your CFHTTP or your data source call or whatever. And we surround that. That means that this code will be executed in a separate thread, and that thread is independent of the current thread running. So Lucee will not wait, or the current thread from Lucee will not wait until this thread end. So when we call that function, it opens a new thread, calls, sleeps, and just go on. So it doesn't wait for it. So when you execute that, you see it only took a millisecond to execute that, so it wasn't waiting for it. Next example, we do the same for multiple threads. So we call that at that time we call it 5 times, and that will be more or less, we simply output also the time it took. When we execute that, we see also takes only 6 milliseconds. So, but maybe we are interested in what the threads are doing, or in the result of the thread. So what we always can do is we have the scope CF thread, and when I output that, see, I have not expanded, so I see this 5 threads. And when I go into a thread, I see the status is still running. So I also see where it is at the moment. It is in the multiple CFM file on line 6, and it's still running. That is the case, I assume, for all threads. So they are all running. They're all running. So maybe, and also maybe you saw that I here write to the thread scope the start time and the end time. So I will see maybe the start time already, that is already set in that case, but I don't have the end time because it's still running. So maybe I want to wait until all threads end. So what I can do is I simply make a action join, and then I define take the key list, that is this keys here, and say, okay, join this thread. So I'm waiting for this thread to end. I can only define a part of the keys or all the keys. In that case, I take all the keys. I wait for all threads to end, and then I dump again the result that then should be completed and no longer running, because we wait until the end, and we again put out a time. So when we execute that, you see, first of all, we have a second dump, and we always have the end time, as you see here, and you see the thread is completed. That's case for for all threads. Also, this one is completed. We see the end time here. And what is important is that you see it took only a second to execute. So we waited for it, and they spent a second in every single thread, but we don't have to wait 5 seconds because they run parallel to each other. So this we just have to wait for the slowest one. In that case, a second or a little bit more. So that's the benefit of this. So if you want to call a lot of URLs, for example, to check if they're available, you don't have to do that one after the other. You can do that call all of them at the same time. Of course, that so far I showed all example in script because the script is easier to read in my opinion, but maybe you prefer tags to do stuff. So this is the same example with tags. So when I execute that one, you see I get the same result. It's exactly the same. What I did a little bit differently, I did define a name for the thread. That is optional. You don't have to do that. If you do that, you see there are easier to read, T1, T2, and in the other example it was more cryptic. That was a generated name. If you don't use it directly in the code, it doesn't matter, but maybe you prefer that. You can do that. It's an easy way to do that. Simply set the name. What you also can do is set the action, say action run. That's the default action. You don't have to define the action, but because that's the default action. So we try to simplify that as much as possible. So otherwise, you see that's the same. In that case, I don't wait for all of the threads. I only wait for T1 to T3. So when we again look at the code, sure if that's the right one. So you will see. What I also did is I'm increasing the sleep time for every call. I take the index. Set, and the first one takes 1000 milliseconds and 10, and then 10,020, 20,030, and so on. So I increase the time they take to execute, and I only join T1 to T3. That means when I look in the code, T1 until T3 they are completed, but T5, for example, is still running at that point of time because I don't join this one. You can do that selectively if you prefer. Okay, close some of them. Okay, there are other ways to do in a simpler way the same. So what we did is that more or less that was parallel execution of functionality. You can also do that with the each functionality, with the each function. You see here I have an array with 2 elements inside. That can be whatever you like. And then I simply call each on that array. This array takes then, this function then takes a closure, a function that is called for each element in the array. So when I execute that, you see it took 2 seconds because we have 2 elements and it's for each element it sleeps a second. But of course when I have the function each has a optional argument called parallel. So when I set that to true, that can be false or true. Default is false. When I set to true, it executes each element in the array parallel. So with a single thread, separate thread. When I call that again, you see we are down to a seconds because each one takes a second. It's parallel execution. So it's more or less the same as we had before, but it's simplified. It's much simpler to do that way. So now we extend that a little bit. in previous example, we only had 2 elements, and now we do 100 elements in that array. You see, okay, I have 100 elements. Each element takes a second to execute. That should still be 1 second, right? So when I execute that, take a little bit of time. Okay, it took 5 seconds and not 1 second. So why is that? Should be one only. The reason for that is that when you have 100 elements does not mean that each function opens 100 threads to do that. The reason for this is that threads are a limited resource, so you can't open as much threads as you like. Because of that, in that case, we have 100 elements. That doesn't mean that Lucee opens 100 threads to achieve that. So it only opens by default 20 threads. So that means you always have to others have to wait until there are more free threads. So threads are reused. What I can do, I can change the value of how many threads are maximal used. So in that case, I set that to 100. That means it will use 100 threads parallel. So when I execute it again, you see we go down to a second. So now it hasn't that limit anymore, but we waste more threads. So there you have to find a balance between how many threads you are wasting and how much time you win by wasting these threads. Each function was about the array, but each is supported by other types. So when you look closer, you have each. This is the array example. You can also do array each. You don't have to use the member function. You can do array each in the same way. You have the same functionality for structs. So you do struct each, or simply from the struct call also each. And you even have it for queries. So in that case, I do it query, and then I do query each, pass the query, the closure, or I simply call each from the query. So when I execute that, in that case, I output everything on the command line. Makes it easier to read. So when I execute that, and I look on the command line, you see at the end here we have this. The first ones are the output from the array, then you have the output from the struct, and the output from the query. Of course, you get different arguments in, but in the end, it's all the same. So that is what so far exists in Lucee, but for us, that's not the end. We are discussing for a long time how we could extend that functionality to make it easier to use, or add new functionality with thread-based functionality. And these are just some ideas. Maybe you have other ideas. If you have, please comment in all our channels what you would like to see or what you miss most when it comes to threads. First thing is a very simple thing, like I just explained. By default, you have maximal 20 threads, and this is very a fixed value, and it's hard to know what is the right one, how many threads my system can produce, and what's a good value. That's hard to know. So what we plan to do is we use instead a thread pool. That is something supported by the JVM. That's the executor service. So you don't have to take care of how many threads you are using at all. The system will do that and will make the best choice for you. A choice you don't know what's the right one yourself. So that's something we are planning to do, and it will come. That will not change the functionality for you at all. You can simply do it the same way. It simply improves it in the backend. Then we plan to do the same with thread itself, so that you also have, in that case, a pool. That means when you use thread at the moment, you always open a new thread with thread. So when you make a loop and that loops 1,000 times, and you make a thread, you have ends up with 1,000 threads, but could bring you big troubles. And in that case, we plan to also do a pool with thread itself. So functionality will not change at all. It simply makes it more convenient and safer to use. You don't have to be afraid that it breaks the system in any way. That's the idea what comes there. So both backend functionality that changed nothing at the front end. And then with the, as you saw with the each functions, that is a nice feature, and we would like to see that also in other loop structures like the loop tag or for, that you simply can define parallel as well with this loop, or with the for, that's the other, or while, that you can say, okay, make the execution of the body parallel, so that you can use that in an extremely simple way. So much simpler as all the example we had before. Simply set parallel to true, or simply a fourth parameter with for, set it to true, and it will execute the body of the for or the loop tag parallel. So I hope this video was interesting to you. Have a good one.